I am Professor Antonio S. Marahas, and this is Digital Technique Fundamental. Welcome back to our subject, Digital Technique Fundamentals. Our lesson for today is about binary arithmetic. Okay? Now, basically, binary arithmetic is performed in the same manner as in decimal arithmetic. For example, for the binary addition is performed in the same manner as in decimal addition. Okay? So, what we have here is a table of a binary addition. It says here that if you add 0 plus 0, then the answer is 0. If you add 0 plus 1, the answer is 1. And if you have 1 plus 0, the answer is 1. And if you have 1 plus 1, the answer is 0, with a carry of 1 on the next digit. So, example. You have 1, 1, 0, 1, 1 of base 2. We want this added to 1, 1, 1, 0 of base 2. Okay? So, you have here 1 plus 0. In the table, you have 1 plus 0. The answer is 1. Right? Then you have 1, 1. In our table, 1, 1 is 0 with a carry of 1 on the next digit. So, you have 1, 1 is 0 and the carry on the next digit. Then you have 1 plus 0 is 1, right? And then 1 plus 1 is 0 with a carry of 1 on the next digit. Then you have 1 plus 1 is 0 again with a carry of 1 here. And then 0 plus 1 is 1. Okay? Then you have here 1 plus 1 is 0 with a carry of 1. Then bring down 1. This is on base 2. So this will now be your answer for this particular two numbers or binary numbers which are added. Now, if we want this check, all we have to do is to convert this into decimal number. This is for checking purposes only, no? Okay? So you have 11011. What will be the value of this in decimal number? So this is 1, 2, 4, 8, 16. So you have 16 plus 8 is 24. Plus 2 is 26. Plus 1 is 27 of base 10. And then this one here, you have 8 plus 4 is 12. Plus 2 is 14. Right? So, you add this one. 7 plus 4 is 11. Carry 1. 1 plus 2 is 3. Plus 1 is 4. So, 41 of base 10. So, is this binary number here equivalent to 41 in base 10? So, let us see. This is 1, 2, 4, 8, 16, 32. 32 plus 8 is 40. Plus 1 is 41 of base 10. So, they are equal. Okay? That is how binary addition is performed. Okay, so let's have another example on binary addition. Now, example 2 here, if you notice, are in decimal form. For example, 59 of base 10 and 46 of base 10. Okay? We want to perform the binary addition of these particular decimal numbers. So, the first step that we should do is to convert 59 of base 10 into its binary equivalent and 46 of base 10 into its binary equivalent. Okay? So, again, how do we convert 59 of base 10? We make a series of 1. Okay, so this is 1, 2, 4, 8, 16, 32. When we add another one, that becomes 64, which is more than 59, so we will exclude 64 here. Okay? Then we find the number here. Once we add, it would total to 59. So you have 32. Then plus 16, you have 48. Okay? 48 plus 8 is 56. Alright? And then, the total is already 56. So what is lacking is 3. 0. And then 2 plus 1 is 3. So that is equivalent to 59. So in other words, the binary equivalent of 59 is 111011 of base 2. How about 46? So you have 1, 0, you have 40, 44, 46. Okay, so that is 46. So you have plus 1, 0, 1, 1, 1, 0 of base 2. Then we add these two binary equivalent of this decimal number. So you have 1 plus 0. It says here 1 plus 0 is 1. So you have 1. 1 plus 1 is 0 with a carry of 1. Then 1 plus 0 is 1. 1 plus 1 is 0 with a carry of 1. Alright? Then 1 plus 1 here is 0 again. Carry 1. 0 plus 1 is 1. Then 1 plus 1 is 0. Carry 1. 0 plus 0 is 0. Then 1 plus 1 is 0 again. Carry 1. So you have 0 plus 1 is 1. Bring down 1 of base 2. So this will now be the binary equivalent of whatever will be the result of 59 plus 46. In this case, this is what? This is 15, carry 1, 9, 10. 105 of base 10. So is this 105? So let's try. You have 1, 2, 4, 8, 16, 32, and 64. So you have 64 plus 32 plus 8 plus 1. Okay? So you have 2 plus 8 is 10, 14, 15. Carry 1. You have 9, 10. That is 105 of base 10. So, that means that this number here and this number are equal. This one here is in the form of decimal number, and this one here is in the form of binary number. So, this is again an example on how to add binary numbers. Okay, so let's have another example. We are still in binary addition. But this time, the given number here has a decimal point. No? So, again, the first step here is to convert these decimal numbers into its binary form. Okay? So, for 41.625, this will be the binary equivalent. So, again, we make a series of 1. Okay? So, this is 1, 2, 4, 8, 16. Add 1. So, you have 32. Okay? So, what is 41? You have 32. When you add 16, that is 48. More than 41. So, this becomes 0. 32 plus 8 is 40. So, you have 41. Okay? So, 32 plus 8 is 40. Plus 1 is 41. So, you make this 0. How about the 0.625? So, you add 1 here going to the right. Okay? So, this one here is 0.5. This one here is 0.25, 0.125, and 0.0625. Again, let me remind you that if you have a binary or a decimal number, once you want it converted into binary, just make use of a 4-digit on the right side. So, this one here is point. What is 0.625? 0.5 and 0.125 is 0.625, correct? So, you have 1, make this 0, and then 1, and then 0. So, that is equivalent to 0.625 because 0.5 plus 0.125 is 0.625 of base 2. So this one here, therefore, is equivalent to 1,0,10,1010 of base 2. Okay? How about 26? So again, we convert 26 into its binary form. So you have 16 is 1, 16 plus 8 is 24. So you make this 1, then this is 26. Alright? 24 plus 2 is 26. So you make this 0 and 0. Okay? You can make this also 0. No? So if you want. Pero, pwede ra po nga, wala siya. Then, point. How about 0.75? 0.5 and 0.25 is 0.75. So you make this 1, 1. The rest is 0 of base 2. Then, we place this here. So you have 1, 1, 1, 0, 1, 0, point 1, 1, 0, 0 of base 2. Then we add 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 0. Carry 1. Bring down the binary point. 1 plus 1 is 0. Carry 1. Okay? 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 1 is 0. Carry 1. 1 plus 0 is 1. Plus 0 is 1. 1 plus 1 is 0. Carry 1. 1 plus 0 is 1. 1 plus 1 is 0. Carry 1. 1 plus 1 is 0. Carry 1. Bring down the carry. Base 2. Okay? So this will be our binary equivalent of whatever the result of this number after adding. Okay? So let's try to add. So you have 5, 7, then 6 plus 7 is 13. Okay? So you add 1 here. You bring down the binary decimal point. So you have 6 plus 1 plus 1 is 8. Then 6. So you have 68.375 of base 10. So the question is this equivalent to this particular binary equivalent? No? Is this decimal number equivalent to this binary number? So let's see. So this one here is 1, 2, 4, 8, 16, 32, 64. Okay? Then 64 plus 4 is 68. Right? Then point, this one here is 0.25, 0.5 I mean, 0.5, 0.25, 0.125, and 0.0625. So you have 0.25 plus 0.125. So 0.25 plus 0.125. Right? So you have 5, 7, 3. That is 0.375 of base 10. So in other words, this one here and this number here, decimal number and binary equivalent are the same. Okay? So, okay. How about if you have these numbers here, binary numbers, and you want to add these 4 binary numbers? Of course, we can still do this using the same procedure that we have in the other example, but it will take a lot of time. Now, I was able to create a system that will make this binary numbers here added in a very fast manner. All we have to do is to follow the note here. No? It says if if even number of ones, then the answer is 0, and if the number of ones is odd, then the answer is 1. The carry is obtained by counting the number of 1 divided by 2. Okay, so let's try this one. So, we count the number of ones. 1, 2. That is even number of ones. So, the answer here is 0. Okay, so how about the carry? So, the number of ones is 1, 2. So, you have 2 divided by 2. So, the carry is 1. So, you add 1 ones here. Okay? So, that is your carry. Then, we count the number of ones here. 1, 2, 3, 4, 5. So, that is odd number. So, the answer is 1. Okay? So, we have 5 number of ones divided by 2. So, you have 2, you have 4. Okay? So, this one here is your number of carry. So, you add 2 ones. Okay? Then, again, you count the number of 1 here. 1, 2, 3, 4, 5. So, again, the answer is 1 because it's an odd number. Okay? Then, the carry is the same here. You have 2 carries because we have 5 ones. Then, we have here 1, 2, 3, 4. So, that is even number. So, the answer is 0. Okay? Then, since you have 1, 2, 3, 4 ones, so you have 4 divided by 2 is 2. Okay? So, that means that this one here is the number of carry. So, you put 2 ones here. Then, you add 1, again you count, 1, 2, 3, 4. The answer again is 0 with 2 carries. Okay? The same as this one here. Then you have 1, 2, 3, 4, 5. So, odd number, 1. Then, the same here. There are 2 carries. Okay? So, you have 1, 2, 3, 4, 5, 6. That is even number. So, you have 0. Okay? Then, 6 number of ones divided by 2 is 3. So, you have 3 ones here. 1, 2, 3. So, then you count the number of ones again. 1, 2, 3, 4, 5. That is odd number. The answer is 1. Then, just like this one here, you have 2 carries. Okay? Then, you count 1, 2, 3, 4 again. That is even number. So, you have 0. Then, 4 divided by 2. So, you have 2. Okay? So, you have 2 carries here. Then, you count 1, 2, 3, 4, 5. That is odd number. That is 1. So, here, 5 divided by 2 is 2. So, you have 2 carries. Then, you count 1, 2, even number. So, you have 0, 1 carry. Bring down 1 of base 2. So, this will be your binary equivalent of this particular numbers or binary numbers that we wanted to add. Okay? So, that's the fastest way on adding these particular numbers or several number of binary numbers we wanted to add. Okay? In the using the short method.